Hello, and welcome back to class. So today's topic is ideal gas equation. Okay, so actually, for all experimental work, measurements, or calculations involving gases, four quantities are important in all experimental work. It is very important. And the first one is the volume, the second one is pressure, the third one is the temperature, and the last one is number of moles or mass. So, of these parameters, three of these parameters appear in the general gas equation. If you remember your Boyle's law, the Charles law, the general gas law, which is the combination of Boyle's law and Charles law. So when we check this formula very well, we have three parameters here, the P, V, and T, where P is the pressure, which is the second one, and V, which is volume, and temperature, which is the temperature. So the only one of the quantities that is not here is the number of moles or mass. Okay, so this equation states that for an ideal gas, PV over T is a constant. So it has also been proven experimentally that equal volume of all gases at the same temperature and pressure contain the same number of molecules. That's our Avogadro's constant or law. Okay, so therefore PV is now equal to RT. Okay, so where R is a constant term in the molar gas constant, so the equation now is called ideal gas equation and holds true for all gases. Okay, so from here we can now put in number of n, a number of moles, I mean to say, which is n. So this equation we are seeing here will now PV nRT. So where n is the number of moles. Okay, so now let's take one example. So a certain amount of gas occupies 5.0 dm cube at 2 atm and 10 degrees Celsius. You have to calculate the number of moles present. Okay, so from the ideal gas equation, we PV equals to nRT. Okay, that's from the ideal gas equation. So the first thing we're going to do is to ask the question, what are we looking for, and the formula to use. So this is the formula to use, and we're asked to calculate the number of moles. So this is the parameter given. N is known as the number of moles, the volume, the pressure, and the temperature. We got to convert it to Kelvin.